right, you guys, question 3 is review from last year, dividing polynomials. So let's go over it, and then if I have time at the end of all of these videos, I'll give you some other practice questions on it. But we have x to the 4th power minus 3x squared plus 5x minus 1. All right, that's our dividend. Our divisor, or what we're dividing by, is x squared minus 3. Okay, and this question is actually asking for the remainder, so keep that in mind when you're coming up with your answer. So here, let's take a look at here. Here we have 2 terms, so we know we're gonna put our original quotient, our first quotient here above the second term, and we want a term that if we multiply by x squared, we get x to the 4th, just like normal long division. In fact, actually, some of you might kill me, but let's do a normal long division problem. Okay, let's do 9 into 122. Okay, 9 can't go into 1, so this is kind of just what I was saying. There's a placeholder there. 9 into 12 is 1 times. 1 times 9 is 9. Subtract. You have 3. Can't go into 3, so you bring down the 2. 9 can go into 32. 3 times 9, 27. And then what is this? 5. Okay? I have nothing else to bring down. Now, if I want the remainder, I'm not going to continue on into decimal form. I'm going to say I have nothing else to bring down. I don't want to have a decimal. My remainder is 5. So if you remember from like early elementary school, you used to write your remainder up here, 5. This is technically the answer that our question is looking for. So let's go back to our question here. So the first one, what times x squared is going to give us x to the 4th? And I hope you realize that that is x squared. Okay, and I'm putting it over the second term. X squared times x squared is x to the 4th. But don't forget I have this other term here, negative 3. So I have to do x squared times negative 3, which is negative 3x squared. Then I subtract, same exact steps that I did for long division. X to the 4th minus x to the 4th. Now look, I put the subtraction sign here, so I'm subtracting. That cancels out. Now, be careful, I'm also subtracting this negative 3x squared. So this subtraction sign actually turns this negative into a positive, which means these actually cancel out also. Don't make that confuse you. If you're taking away something that's exactly the same, if I'm taking away negative 3x squared from negative 3x squared, those are going to cancel out, okay? So I have 0. Obviously, I need to bring down the next 2 terms to continue on. So I'm going to bring down 5x minus 1, right? And x squared minus 3, I'm looking for what can I multiply x squared by to give me 5x. And if you've realized that it is nothing, you are correct. So that means the rest of this, 5x minus 1, is our remainder, 5x minus 1. So the question, the answer to the question here that you would write down, number 3, is 5x minus 1. Okay, that's all I'm looking for. Now, what does that mean? Well, again, let's go back to this original question, remainder 5. If you remember how you write that from elementary school, you would write 13, okay, and 5/9. Okay, so this is 13 plus an additional 5/9. That's what the actual number is. It's the same for functions. If you wanted to write this as a fraction, it would be x squared plus 5x minus 1 over x squared minus 3. Now, what's the next step? If you want to take it even farther, what else does that mean? Well, this means that if I take 13 and 5/9 and I multiply it by 9, I'm going to get 122. Okay? So it means the same thing when you're talking about functions. They're just a lot messier, right? It means if I take this and I multiply it by my original divisor, x squared minus 3, I should get, as a result, x to the 4th minus 3x squared plus 5x minus 1. So does that work? X squared minus 3 times x squared. I know for sure that I've already done that up here, that gets me x to the 4th minus 3x plus, right, I'm distributing it, so I need to multiply this times that second term. Well, if this here is the same as denominator here, those are going to cancel out. So what I have left is 5x minus 1. So that, in fact, works and gives me back, let me move this over, the original equation.